Okay, so we've got 3 questions. What do we mean by the activity of radioactive material? What is the unit used to measure activity? So 2 nice, straightforward questions. And then a equation question. A radioactive material undergoes 4,500 decays in 1 minute. What is the activity? Okay, so are there any volunteers who wants to answer question 1? Jam on. Thank you, Tom. Yeah, okay. Yeah, okay, so how many nuclei disintegrate per second, or how many particles are given off per second, so in a unit of time. Okay, what is the unit used to measure activity? Let's go for someone. Oh, yeah, Alistair. Sorry? Yep, very good. And number 3 was the one where you had to work it out. A radioactive material undergoes 4,500 decays in 1 minute. What is the activity? And I've given you a hint there by writing down the equation. Let's go for Jamie. Yep, how did you work it out? Yep. Yeah, exactly. Brilliant. Yeah, perfect. N is your number of decays, or number of particles given off, so that's 4,500. And T is the time, but it has to be in seconds. You have to change minute into 60 seconds, so it comes to 75. Okay. We got 75 becquerels. Okay. Did anyone have any trouble with any of those questions? No? Okay, good. Right, so we're going to continue with the booklet. So we're on to half-life. I think it's page 7, although my booklet, my page numbers might be slightly different.
How's the seating plan coming along? Keep it coming around. Yeah, thank you. Okay, so we know that activity is the number of nuclei that disintegrate, or the number of radioactive particles given off per second. Okay, so each different radioactive material has a different, what we call half-life, and they're individual to each one. Okay, so say uranium has a different half-life to lead, which has a different half-life to other things. So anything that's sort of slightly radioactivity has a half-life. Okay, and that's how we can identify what the type of atom it is. Okay, and the half-life is the time it takes for the activity to half. Okay, so we know that as time goes on, the activity gets less and less because there's fewer particles to disintegrate. Okay, and so half-life is the time it takes for the activity to get to half. Okay, so radiation from a radioactive source is caused by the nuclei of the atoms of the source decaying to produce a different form of nuclei. The process of radioactive decay is random, so you can't really predict when it will happen, we just know that it will happen. So the time at which any particular nucleus will decay cannot be predicted. However, when a source contains a large number of nuclei, the behavior of the source as a whole can be predicted. Just leave it at the front. Okay. So it's a bit like if you're flipping a coin, okay, you've got heads or tails, okay, and if you flip it 100 times, you can probably say that it's going to be 50-50. Okay, it might be 51-49, but it's around about that. Don't know what's happening out there. Yeah, so it's a kind of thing like that. So if you've got a big enough source with enough particles that are going to decay, then you can predict, but you can't guarantee that it's going to be that. Okay, so it could be you flip a coin 100 times and you get 100 heads. There is a probability that that could happen, but generally you could predict that it was 50-50. Okay, so when a source contains a large number of nuclei, the behavior of the source as a whole can be predicted. And the time taken for half of the nuclei in a radioactive sample to disintegrate is a constant for a given isotope. So for each different element, it's constant. And this time is called the half-life of the isotope. And the activity of a radioactive sample is directly proportional to the number of radioactive nuclei present in the sample. So it's a number of radioactive nuclei half, the activity halves. So there's actually two definitions for half-life there. Those ones that are bold there, So the half-life can be defined in two different ways. These ones here. So you could call it the time taken for half of the radioactive nuclei in the source to decay into another form. Or, I like this one just because it's slightly shorter, the time taken for the activity of a radioactive source to halve. And it's measured in units of time because it's the time taken for something for it to halve. And it could be seconds, minutes, days, years, and it all depends on what type of atom you're talking about. So, for example, uranium-238, the half-life is 4,500,000,000 years, so long time. So it sort of sticks around for a long time. But the half-life of polonium-216 is 0.15 seconds, so it doesn't really stay around for very long. Okay, and that's quite important when we come on to looking at uses of radioactivity. It's very important to know the half-life to see how long something will stay radioactive for. So decay curve. So quite often when we're talking about half-lives, we can plot what we call a decay curve. Okay, so this means it shows you how long it takes for the activity to halve. So here we have the activity versus the time. Okay, and quite often you'll see a half-life written as T half with a little half next to it. That just means half-life. Okay, so if we start off with an activity of 1, then after one half-life, that activity halves. So it gets down to a half. So if it gets to a half after one half-life. Okay, and then after another half-life, it halves again. So if we've got half of a half is a quarter. So after 2 half-lives, we're down at a quarter of the original. Okay, and again, after another half-life, it will half again. So half of a quarter is 8. Yes, the next one is 1/8. Okay, and it'll continue doing that, and it'll get smaller and smaller and smaller. But it's exponential. Have you come across exponential in maths before? Yeah, so it never actually gets to 0, but gets to like very, very close to 0. Because it keeps on halving and halving and halving and halving. Okay. So this table above shows you the same kind of thing. So if we say that the original activity is O for A original. Okay. After one half-life, it gets to half of that. Okay, so half of A0 is A0 divided by 2. After another half-life, it gets to half of that, so you have to half that again. My pen doesn't want to work. So you're basically halving it each time. Let's get rid of that. So you're halving it each time. So after another half-life, it's half again, so it's a quarter of A0 divided by 4. And as you told me earlier, after 3 half-lives, it's a quarter of A0 divided by 2 again, which is an 1/8 of A0, so A0 divided by 8. And after another half-life, it halves again, so it's going to be A0 divided by 16, thank you. And after 5 half-lives, we're halving that one again. So A0 divided by 16 divided by 2 is going to be A0 divided by 32. Okay, so each half-life, you're halving it again. Okay. So this is where your sort of calculator comes in handy, because you can just keep pressing divide by 2, answer divided by 2, answer divided by 2, okay, to get to your eventual answer. Okay. Is this making sense? Are there any questions so far? No? Okay. Right, so we're going to go through some examples of this, okay? These examples can get a little bit tricky, but as long as you take it step by step, you'll be fine, okay? So the trick with answering these questions is walking through it step by step. So if you turn over the page, we'll just finish up. After 1 half-life, the activity drops to half its original value. After 2 half-lives, it drops by half again. There's a quarter of the original value. After a 3rd half-life, it half again and it's 1/8. Okay, so example 1. The half-life of radioactive iodine 131 is 8 days. So that means the time it takes for the activity to half is 8 days. A sample has an activity of 1,600 kilobecquerels on the 5th of September.
calculate the activity on the 29th of September. Okay, so the first thing to do when you're answering these questions is just to write down what you've been given in the question. So we know that the half-life I think my battery needs replacing my pen. Half-life is 8 days. Okay. We also know that it originally has an activity of 1,600 kilobecquerels. So we can say original activity I do apologise about this pen. Kilobecquerels. 1,600 kilobecquerels. Original activity, that should say. Okay. So we know that's on the 5th of September. We want to know what the activity will be on the 29th of September. So we need to know how many days have passed. Okay. So 5th of September to the 29th of September. How many days have passed? Yes. Okay. So some of you might be thinking, sort of be able to think what you're going to do next. So we've got 24 days. We want to know what the activity will be after 24 days. Exactly, yes. So we know one half-life is 8 days. So 8 times 2 is 16, times 3 is 24. So 3 half-lives have passed. Okay? So don't worry if you couldn't think of that. Don't worry. Again, it's one of these step things. So how many half-lives have passed? It's basically how many half-lives are in that 24 days. So 3. Okay, so if we know that the original activity is 1,600 kilobecquerels, and we know that 3 half-lives passed, to find the final activity, we have to divide by 2 3 times. Okay, so what I do is I do a little sort of ladder. Okay, so we had 1,600 original, this is kilobecquerels. So if I divide it by 2 once, it gets to 800. Okay, that's after 1 half-life, but we know there's 3 half-lives have passed. So we have to do that 2 more times. So 800. Somebody switch that off, please. Thank you. 800 divided by 2 is 400. So that's after 2 half-lives. So we need to do it again. So 400 divided by 2 is 200. And that's after 3 half-lives. So the answer is 200 kilobecquerels. Okay, so basically, one question, yep. Yeah, if you're happy with that maths, yeah, that's absolutely fine. Is that what you're going to ask as well? Yeah, you can do that as well. Yeah. The reason that I don't teach you that way is like a lot of people will get really mixed up with indices. But if you're happy doing that, then that's absolutely fine. Yeah. And this kind of shows what we're doing. But if you're happy with using indices, that's absolutely fine. Yep.
See how this is asking for the activity?
Yeah.
This question.
Yeah.
Could it be asking for different, say it could be asking for how many half-lives, so you just put 3 and it's not the...
Yeah. Yeah, exactly, yeah. So you'll see there's a couple more examples we're going to go through and they'll be asking for different things as well. But yeah, if it just said how many half-lives, you just leave it there. Okay, has everyone got that? Okay, example 2.
a cobalt-60 source has an activity of 7.2 megabecquerels. After a period of 26.5 years, the source has an activity of 225 kilobecquerels. Okay, so we've gone from mega to kilo. Calculate the half-life of cobalt-60. Okay, so for this one, we started off with 7.2 megabecquerels, so that's 7.2 million becquerels. Okay, so original activity equals, I'm going to write it out in becquerels just so we don't get mixed up. So that's going to be 7,200,000. Okay, so if you have got two different units, make sure you put them all into the same unit. So you could put them both into kilobecquerels if you prefer, but I'm just going to put them all into the becquerels. Okay, and after 26.5 years, we have 225,000 becquerels. So we need to know how many half-lives have passed in 26.5 years. Okay, so this, again, we do the ladder. Okay, so we're starting off with 7,200,000 becquerels. We divide it by 2 equals. Divide that by 2 equals, until we get to our desired number, which is 225,000 becquerels. So start off 7,200,000. And you could just do this on your calculator, so you could go put the number in, divide by 2 equals, and then you do answer divided by 2 equals, answer divided by 2 equals. So see if you can work out how many times you have to half to get to that. And if you can work out a different way to do it in terms of maths, feel free to use that. So you're trying to get to 225,000, so start, divide by 2 equals, answer divided by 2 equals, answer divided by 2 equals, until you get to the one that you're looking for. So I'm still not there, and I'm on 4. So I've got Earth after 5 half-lives. That's not the answer to the question though, because the question says calculate the half-life of cobalt-60. So 5 half-lives have passed in how many years? Was it 26.5 years? Therefore, that's a shorthand way to write, therefore, 1 half-life is going to be that divided by 5. we've got one more example to go through as a class, and then I'll let you guys have a go at some of these. Really, with this one, it's just practice, 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 and you'll get there. In fact, you can have a go at question A, have a go at the next one, example 3, while I look this up, because I think some people are still writing. So if you have it written out, just have a read through and see if you can have a go at the next example. Is anybody still writing? Okay, can move on. So remember, write down everything you are given in the question first of all.
Can you just take the answer for 38? Can you just take the answer from example 1?
So it is, yeah. But in case you didn't have that, we can go through how to work it out. Okay, so we've got after 24 days, the activity of a sample of iodine 131 decreases from 80 kilobecquerels to 10 kilobecquerels. A asks you to find what the half-life of iodine 131 is. So we've got original activity of 80 kilobecquerels, and it decreases to 10 kilobecquerels after 24 days. So we want to know how many times you divided by 2 to get to 10. Okay, so you can do the ladder thing again. So 80 divided by 2 is 40, so that's 1. 40 divided by 2 is 20, that's 2. And 20 divided by 2 is 10. So we've had 3 half-lives. Passed in 24 days. So 1 half-life is 24 divided by 3, so 8 days. Everyone okay with that? And again, by all means, have a stab at part B. So it's all about dividing by 2, over and over again. Okay, so for part B, you want to find how many times you're halving it. So how many times you halve 10 to get to 2.5. That's how many half-lives there are. You know, 1 half-life is 8 days. So 10 divided by 2 is 5. That's 1 half-life. 5 divided by 2 is 2.5. So only 2 half-lives have passed. So 2 times 8, 16 days. Okay. So I'm going to get you guys to do some of these questions. As I said, the more you do them, the more they'll come to you But there are different ways. They might ask you what half-life is. They might ask you how much time it takes to get from one place to one activity to another. It might even ask you to find the original activity if you know the rest of the stuff. Okay. So the questions I would like you to have a go at. I do apologise about the question booklet. It's not in any, logical order. So the questions that I'd like you to have a go at are 20, 23, 24, 25, 32, 33, 34, 36, 37, and 54 to 59. I don't think you'll get through all of them, but you can make a start on some of them. Please do ask me questions.